Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. We have finished our Algebra 1 and 2 course. I'm very proud of you. Now we're going to go ahead and add a little bit of trig. And we're going to start with, as you can see, trig part 1. This is not coming from a book. This is coming from my own notes. So you will have PDFs that I will post for you to practice, okay? Today we're going to talk about right triangle ratios. Basically, trigonometry is right triangle geometry. It deals with right triangles, believe it or not, within a circle. It's pretty cool. Trigonometry is used for all sorts of cool applications. For example, if you've ever driven a car, okay, the way your pistons move and your belts move, those circular motions, those are all measured with trigonometric ratios. The way a clock works is a trigonometric ratio. The way sound waves move is a trigonometric ratio. The way that they have a GPS, it's called it's triangulating where you are. That's trigonometric ratio. When they're looking for something or someone out at sea, trigonometric ratio. When you want to find the distance from one point across to the other point of a huge river that you cannot cross, trigonometric ratios. Trigonometric ratios are actually really powerful. Trig is really powerful. You want to find the height of a building? With the right trigonometric ratios, I could find the height of a building by just looking up and doing a couple calculations. It's that powerful. So let's get to it. First of all, since we're talking about right triangle ratios today, and trigonometry is based on right triangle geometry, let's investigate this right triangle, okay? I am labeling each of these sides. Please pay attention to this. With respect to angle A, or this little symbol here that's called theta. This guy is called theta. It's a Greek letter. There's going to be a lot of Greek letters in trigonometry. Theta, alpha, beta. Theta is very popular though, okay? From this angle theta, from this angle, and from this angle alone, across the angle is called my opposite side. And my opposite side, as you can see, is parallel to the y-axis. So my opposite values relate to the y-axis. From theta, the angle directly next to it is called my adjacent. Adjacent means next to. Now, almost every one of my students in the past have said, whoa, Mr. Morrow, but there's two angles, there's two sides that are adjacent. You have the one that you called adjacent, but you have this guy too. Okay, this guy here, you're right. It is adjacent, but it is never called the adjacent. Why? Because it is called the hypotenuse. It will always be across the 90-degree angle. The hypotenuse is never the opposite, and it is never the adjacent. The hypotenuse is its own value. It's hypotenuse, period. Okay? So from any particular angle in a right triangle, you can find the opposite. That's the one that it's across from the angle. The adjacent, that's the one that's right next to the angle. And the hypotenuse, that is the largest side, and it is also the side opposite the 90. You with me so far? Now let's put this bad boy into a circle. If we put this right triangle into a circle, my hypotenuse is my R, which represents the radius of that particular circle. Okay? The X, that is my adjacent when we're talking in respect to angle theta. And my Y is my opposite with respect to my angle theta. This point P That is just the point on the circle. When we're dealing with angles in trigonometry, you have to realize, picture this is part of a motor, okay? This little point is traveling around this circle at a certain speed, and it keeps traveling around this circle at a certain speed, and it keeps traveling and keeps traveling. I can find the location of where it travels by using my trig functions. Okay? We're not going to work with the unit circle. We're not going to work with a lot of circle trigonometry this half of the year. You'll learn that next year. But I want to introduce the concept. Why are we doing this? What is this all for? So basically, we're looking at angle measures, movement within a circle. Is everyone with me so far? Okay, now, since we're dealing with right triangle trigonometry, you have this formula here. It's r squared equals x squared plus y squared. You've probably seen this before as c squared equals a squared plus b squared. That does not look like an a. Okay. All right, that's called the Pythagorean theorem. Same thing, except your r is your hypotenuse, but that's the radius. And instead of a, there's an x, and instead of b, there's a y. Same difference, though. The x and the y are the sides of the right triangle. The r is the hypotenuse. Make sense so far? Okay. Now, from this triangle, I can get the trigonometric ratios. Remember that we're talking about a right triangle here. And this time we're going to use this as A, okay? This will be my opposite. Bless you. This will be my adjacent. That would be my hypotenuse. Why, Mr. Morrow? From A, the opposite is across. The adjacent is right next to. And the hypotenuse is always across the 90. I'm going to repeat this a lot, because once you get that entrenched in your brain, things get a lot easier. So, the sine. The sine on your calculator is sin, S-I-N. The sine of angle theta, wherever angle theta is, in this case, angle theta is right here, angle A, it's opposite over hypotenuse. So the opposite side of that angle over the hypotenuse will give you a value for the sine. That is one type of trigonometric ratio. You have a cosine. The cosine is a trigonometric ratio of the adjacent over the hypotenuse. The tangent. The tangent is the trigonometric ratio of the opposite of the angle over the adjacent of the angle. Now, you may be looking at this and saying, how am I supposed to remember this? Well, that's where this little weird nomenclature comes from. It's called SOHCAHTOA. Learn it, laugh when you say it, it doesn't matter, but memorize it. SOHCAHTOA. So, opposite over hypotenuse. Check. Ka. Adjacent over hypotenuse. Check. Toa. Opposite over adjacent. Yeah, I'm glad you're laughing. Hopefully you remember by the laughter, okay? So, SOHCAHTOA. Now, these are the three main trigonometric ratios, but there are three reciprocal trigonometric ratios. The reciprocal of the sine is called the cosecant. And you know what a reciprocal is already. You flip it, right? So if the sine is opposite over hypotenuse, the cosecant is hypotenuse over opposite. The reciprocal of the cosine is the secant. Pay attention to that. Sine goes to cosecant. Cosine goes to secant. Why did they do it that way? I don't know. but that's the way it is. Secant is the reciprocal of cosine. So it is going to be hypotenuse over adjacent. And cotangent, that's the one that really makes sense, is the reciprocal of tangent. And tangent is opposite over adjacent. So my cotangent is adjacent over opposite. You with me here so far? All right. Don't freak out. Okay. Trig function values come from special right triangles that are within what's called a unit circle. And a unit circle is basically a circle with a radius of 1. You're going to learn a lot more about that next year, but basically, this is a unit circle, okay, where the radius is 1. So that's 1, 0, that's 0, 1, it's negative 1, 0, and that's 0, negative 1. From the unit circle is where we get all of our trig values, all of our trig function values. How does this work? How do these special right triangles work? What is the big deal? Okay, first one you've got here is called a 45, 45, 90. Notice here how you have a 45-degree angle and a 45-degree angle. When you have two angles that are the same within a right triangle, the sides are going to be equal. So the opposite or the adjacent, it doesn't matter, the sides of a 45, 45, 90 are always 1. The hypotenuse of a 45, 45, 90 is always square root of 2. Period. Memorize it, learn it, live it, love it. Always. For a 30, 60, 90 triangle, again, all of these are etched in stone. This is going to be a 30, 60, 90 forever. It doesn't matter how big of an angle they want. If it derives from a 30, 60, 90, all of these values are valid. So across the 30, since it's the smallest angle, you have the smallest side, which is a 1. Across the 90, it's always double the small side, so that's 2. And across the 60 is the small side times radical 3, so it's radical 3. So a 45, 45, 90, the sides are 1. The hypotenuse is square root of 2. The 30, 60, 90, opposite of the 30 is a 1. Opposite of the 90, or in other words, the hypotenuse is a 2. And opposite the 60 is a square root of 3. Now, that's great, Mr. Morrow. That looks beautiful. What do we do with this? Let me show you. If I want to find the sine of 30 degrees, doesn't sine equal opposite sole over hypotenuse? Check it out, guys. Sine of 30. Who's the opposite of 30 here? 1. Who's the hypotenuse here, guys? Guess what? The sine of 30 is 1/2. Now you tell me that's hard. The theta in this case is 30. Very good. Thank you. That is the angle measure. Sir? What do you do with that 1/2? That is the value of the sine of 30 degrees. So what that means is, in this unit circle, okay, when this point goes up 30 degrees, the value of that movement is equal to 1/2 of whatever unit you're working with. So when your engine is moving and it goes 30 degrees, the sine of those 30 degrees that it moved was 1/2 of a unit. What if I wanted the tangent of 45? Tangent is TOA, right? So that's opposite over adjacent. So the tangent of 45, you could use this guy or this guy, it doesn't matter. So opposite over adjacent, that'd be 1 over 1. So the tangent of 45 degrees equals 1. That is the value. Now, You are not going to have to memorize what I'm going to show you yet. You will have to memorize it next year. Keep these notes. Check it out. I already created a table of every possible 30, 60, 45, or 90 for you. I did it all. Not because I'm such a genius. I just followed directions. For example, let's look at how I got the cosecant of 45 degrees. You ready? I want the cosecant of 45. At this point in time, all you need to do is memorize these two triangles. If I have memorized these two triangles, I said I want the cosecant of 45 degrees. Well, the cosecant is the reciprocal of the sine, correct? Sine is so, opposite of a hypotenuse. So the cosecant would be the reciprocal hypotenuse over opposite. So you ready? From 45, ready? Hypotenuse over opposite. That's how I got the square root of 2. Does that make sense, boys? This, I promise you, will become second nature to you one day. Radians, you may be asking, what is this? Don't worry about it yet. That is how you describe degrees in a unit circle with radians, but we're not going to worry about that yet. Yes, sir. Is it possible to have negatives? Yes. Depending on what quadrant you're in and depending how large the angle is, but we're not going to do that. I just want to show you the basics in the first quadrant just so you could understand how to find the sine of an angle. Just so you can understand the concept, okay? It's going to get a lot more complicated than this. But if you know this triangle here, these two triangles, I promise you, you're set. I promise you. Okay? Is everyone with me so far? All right, let's put this to play. Find the 6 trigonometric functions from angle theta. Okay. First of all, I've got a missing side here. But I've got a right triangle here, right? So I can find x squared equals 3 squared plus 4 squared, because it's the Pythagorean theorem that we already talked about. X squared will equal 25. Square root both sides. X equals plus or minus 5, but you can't have a negative 5 as a side. So x equals 5. Now, from theta, guys, from theta, I want to find the 6 trigonometric functions. If I were you, since you're learning, I would label the sides right now. From angle theta, that's your opposite. From angle theta, that's your adjacent, and this is always the hypotenuse. Okay? So I want to find all 6 trigonometric functions. Easy. So the sine of theta. Sine of theta is opposite over hypotenuse, so it equals 4/5. Let's find the reciprocal. The cosecant of theta. That's the reciprocal, so that'd be hypotenuse over opposite, which is 5/4. You with me here? Cosine of theta. Cosine of theta is adjacent over hypotenuse, so in this case it would be adjacent over hypotenuse, 3/5. The reciprocal of the cosine is the secant. Secant of theta would be the reciprocal, the opposite, the reciprocal. So it's hypotenuse over adjacent, which is 5/3. If I want the value of the tangent of theta, tangent TOA, opposite over adjacent, is 4/3. And the cotangent of theta is the reciprocal of the tangent, so it's going to be adjacent over opposite, which is 3/4. You just found the value of all 6 trig functions from this particular theta. Do you know what that theta is? No, not yet. I'm going to teach you that in a second. All you found right now was the value of that particular theta for each of the 6 trig functions. Not bad, right? Okay. Find the 6 trigonometric functions for angle theta. Okay. Again, label, label, label. From angle theta, the 3 is opposite. The 10 is adjacent. And the square root of 5 is always a hypotenuse because it's across the 90. So, katoa, sine of theta, opposite over hypotenuse. 3 over radical 5. But can I have a square root of 5 in the denominator, guys? Now, we've already learned that. We have to rationalize. So I'm going to multiply square root of 5 over square root of 5. So the sine of theta really equals 3 square root of 5 over 5. What's the cosecant, though, of theta? Square root of 5 over 3, right? Is the hypotenuse over, let me make that clear. It's the hypotenuse over the opposite. You do not have to rationalize there. Not because it's in the numerator. Yeah, 3 over square root of 5, what is the reciprocal of that? Square root of 5 over 3. But whenever you have a radical in the denominator, you must rationalize. Thank you, sir. Cosine. Cosine of this particular theta is adjacent over hypotenuse. So 10 over square root of 5, rationalize. So that's going to be 10 radical 5 over 5, which is 2 radical 5. But what is the secant? Well, the secant of theta is the reciprocal of the cosine. So it's hypotenuse over adjacent, which is square root of 5 over 10. Tangent. Toa. Opposite over adjacent. Bless you. 3/10. Cotangent. It's the reciprocal of the tangent. So it's adjacent over opposite, which is 10/3. How are we doing here, boys? Talk to me. Some of you shook your head. Come on, talk to me. What's up? Yeah, remembering it, that's going to just take time. That's going to take time. Okay, what if I do this? The cosine of A is 2/5. Find the tangent of A. Huh? Think. We're coming from angle A, right? That's my theta right here, A. The cosine from angle A, isn't cosine ka adjacent over hypotenuse? So isn't the adjacent 2? Isn't the hypotenuse 5? Do you guys see that? Now let's find this guy. Let's find my opposite, right? Well, 5 squared equals 2 squared plus my opposite squared. So 25 minus 4 is 21 equals x squared. So x equals the square root of 21. So my opposite is now square root of 21. Does that make sense? Now that I have all the values, I want the tangent of A. Toa. Tangent of theta, tangent of angle A would be opposite over adjacent, square root of 21 over 2. Guess what, guys? You're doing trig. Does that make sense, boys? You promise? Katoa, remember that? And remember the special right triangles. A 45, 45, 90. Sides are 1 and 1. Hypotenuse square root of 2. A 30, 60, 90. Across the 30 is 1. Across the 60 is square root of 3. The hypotenuse is 2. May I continue? Okay. Now the fun part. Warning. When calculating trig functions using degrees, because you could calculate it using radians, which you'll learn about later. But I just don't want you to see radians and go, oh, Mr. Moore never told us. Radians are another type of way to measure degrees, or angle measures, rather. So when we're going to be using degrees. When you want degrees, please remember to set your calculator to degree mode. We already talked about that, but here's just a little reminder. You can always test to see if you're in degree mode by finding the sine of 90. It has to equal 1 when you're in degrees. If it equals 0.89, you're in radians. If the displayed answer is 1, then your calculator is set in degrees. If the display is not 1, then you must change your calculator mode to degrees. Okay? Now, remember how we were finding the value of theta, guys? We had this, whatever, this is 3, that's 8, and that's 7, right? Okay. Remember that I said sine of theta equals opposite over hypotenuse, right? That's the value of that particular theta. Well, right now we're going to talk about how to find the value when I give you a degree already. In order to find the value of a trigonometric function, simply use the sine, cosine, or tangent keys for that particular angle measure. In order to find the value of the reciprocal trig functions, use the sine, cosine, tangent keys for that particular angle measure, and then reciprocate the answer. Why? Because the cosecant is the reciprocal of sine. The secant is the reciprocal of cosine. And the cotangent is the reciprocal of tangent. Okay, guys, sorry about that. So, we're going to use our actual calculator to find crazy values. For example, I want everyone to put in their calculator sine and then put in 48 degrees. What is the value of the sine of 48 degrees? Sir, 0.743. Did everyone get that? You just found the value of the sine of 48 degrees. That is the value. So when an angle is moving and it's at 48 degrees, the value of the sine of that 48 degrees is 0.743. Okay, we're going to do a lot more examples, but just wanted to show you. In order to find the measure of the angle, please be careful with this. To find the value, you use sine, cosine, tangent. Okay? To find the angle measure, you want to find the theta, the missing angle. 1. To find the sine, you use the sine to the -1. It's called the inverse of sine. It's called the inverse because instead of finding a value, you're now finding the degree. For most of your calculators, okay, there's a little second or third button, and you have to hit that before you activate your inverse sine. For your calculator, you have to hit it twice. Okay, good man. So, for sine, use the inverse sine. For cosine, use the inverse cosine. For tangent, use the inverse tangent, which are activated again by a third or second function key depending on your calculator. Let me give you an example. I want to find the angle measure, the theta of the sine of some theta equals 1/2. In your calculator, go ahead and hit second or third function key. So you have the sine of inverse -1 and put the value 1/2. You should get an answer that says 30 degrees. Does that make sense, boys? Okay. And last but not least, this one's a little tricky. In order to find the measure of the angle, again, the angle measure, the missing angle of a cosecant, pay attention, you're going to use the inverse sign, okay, and you reciprocate the answer or the value that they gave you originally. For secant, use the inverse of cosine, reciprocate the answer or the value that they gave you. For cotangent, use the inverse of tangent and reciprocate the answer or the value that they gave you. Let me explain what I'm talking about. If I say to you, find the following theta, I say secant, I say the secant of some angle theta equals 4/7. Okay? Step 1. Who does secant belong to? Sine or cosine? Cosine. So go inverse cosine of 7/4. You have secant, so that activates the inverse cosine. But it's secant. So the answer they gave you, the value they gave you, must be reciprocated. What do you get? Okay, good. It's undefined. Very good. In that case, let's try the other way. What's the secant? What's the theta, rather, of 7/4? In this case, you're going to go cosine inverse of 4/7. What does that give you? Go ahead, 55 point. 55 point what? There it is, 0.15 degrees. That value of 7/4 when responding to the secant came from an angle measure of 55.15 degrees. Does this make sense, guys? Believe it or not, you're learning a huge amount today, guys. This is like 3 sections put into one. I'm very proud of you, as always. Okay, let's just practice a little bit. Solve triangle ABC. Solve, what does that mean? That means I want to find all missing sides and angles. I have all my sides, but I don't have this angle, B, and I don't have this angle, A, right? So let's first look at angle B. I want to find angle B. So since I have all the sides, I can choose any trig function I want. So me, I'm going to use sine. So the inverse sine of opposite over hypotenuse. Can you please give me that answer, my brothers? Inverse sine of 12/13. 67.38. Awesome. That's angle B, guys. Now, how many degrees are in a triangle? So guys, do me a favor and go 180 minus the 90 minus the 67.38 you just found. What is angle A then? 22.62. Very good. Guys, you just know now how to solve a right triangle. Yes, sir. Why did I use the inverse? Can anyone answer that question for me? Why did I use the inverse? What is the inverse used for? What is the inverse used for, guys? Say it out loud. It's the measure of the angle. Did I have the angle measure there, my brother? No, thank you so much. Does that make sense? Okay. Right quick. Find the measure of the angle. How do we find the measure of this angle? And did I mess this up? Wait. No, that's fine. Okay, how do I find the measure of this angle? Cosine of theta is 1/2, so go inverse cosine of theta. Should be 60 degrees. Oh yeah. Tangent of theta equals 0.786. I want to find that theta. So, inverse tangent of 0.786. What does that theta equal, gentlemen? 38.17 degrees. Done. Cotangent of theta. Okay, wait a second. Cotangent goes to who? Tangent. So I'm going to go inverse tangent of 1 divided by 1.6. Remember, it's the reciprocal. Always. What do I get? What's my answer? What's my theta? What is it? On the dot? Perfect, 32 degrees. Sine of theta is equal to 1. So what's that theta? I'm going to go inverse sine of 1, and that should equal 90. Yes. Very good. Secant of theta. Who does secant belong to? So I go inverse cosine of the reciprocal of the answer they gave me. What does that give me, my brothers? Domain error, okay? That means it's undefined. Very good, and it is undefined. How about the cosecant of 8/5? Who does cosecant belong to? So inverse of sine of 5/8. Remember, you have to reciprocate the answer they gave you. What does that give you? 38.68. So my theta equals 38.68 degrees. No, good question. The question was, don't you have to rationalize this part? No, because you're going to reciprocate this. The calculator will do that for you. Okay? Now, you can try it if you want. Why don't you do this, just to prove that I'm right. If I rationalize that, that's going to be 2 radical 3 over 3. Go ahead and find the cosine inverse of 2 radical 3 divided by 3. Domain error, of course. It's going to be that way regardless. And last but not least, sorry about that. These are just easy Mickey Mouse ones. Okay? I could use this 2 ways. I could set up a right triangle, or I could use the calculator. So let's just use the calculator just so you get the flow of it. So cosine of 30 equals? Guys, equals? Come on, cosine 30 equals? Huh? Square root of 3 over 2. What is it in decimal form for those of you that didn't come out like that? 0.867. Good. What's sine of 45? It's 1. I'm sorry, it's not 1. It is square root of 2 over 2. Sorry. For homework, do these. We'll go over them tomorrow, and I will post a practice for you, okay? You learned a lot, guys. Thank you so much. Have a great day. Bye-bye. Get out of here.